When given the vertex and a point, what we're going to do is we're going to plug in the vertex for hk into the form y equals a, h minus x minus h, the quantity squared, plus k. Then we're going to plug in the given point for x, y. So you're going to be either told a point or you're going to be able to look at a graph and pick out a point. So that'll go in for the x and y. And then we will solve for the a, which remember tells us whether it opens up or down. So we'll plug all those things in and we'll get an equation. We're also talking today about how to move that thing in vertex form back to standard form. We're going to use, I'm going to call it double distribution. Multiplying each to each, FOIL, whatever you want to call it. We use double distribution to multiply the binomials together. We distribute the a to all three terms, and then we add k at the end.
So what was the parameter on the left?
This quadratic is currently in standard form. Okay, a is -1, b is 2, and c is 3. So let's start by getting our vertex by doing the axis of symmetry, -b over 2a. You can do this on your own paper. If you feel confident in it, go ahead. b is +2, so it's -2 over 2 times -1. So I get +1.
Yep.
Oh, I like when that happens. So the x value of the vertex is 1. Now we need the y value. Let's plug back in. I'm going to write f of x, f of 1, which means, remember, I'm just inputting 1 into the function. That's all that means. Is negative, careful, 1 squared. You do the exponent first and then multiply by -1 after. Plus 2 times 1 plus 3. So that would be -1 plus 2 plus 3. What do I get, guys?
4.
Brilliant. Yay, we have a vertex. It's at 1, 4. That's nice. So that means that my hk is 1, 4. So let's make sure we understand. This is a vertex. This is hk. This is vertex form, a x minus h squared plus k. We know that h is 1 and k is 4. So let's replace those numbers. Make sure that it stays x minus 1 squared plus 4. Remember, we changed the sign on the h. We're just subtracting that value. If you can look at the steps at the top, next thing it says is plug in the given point for x, y. Think about that. The given point, which means without solving for another point. So can you please talk to the person next to you? What other point do you know without solving anything? Can someone please tell me what point we already know without doing any solving? Ben? 2, 3. No, x and y don't mean, or b and c are just numbers in front of the variables. I appreciate you taking a risk. That is incorrect. Safik? The y-intercept. 3 means something. I take that back. B doesn't really mean anything. The 3 means something. Together, they mean nothing. So the 3 is our y-intercept because the c term. So we have a point at 0, 3. It's my y-intercept. So we're going to use that point. And we're going to plug that point in for x and y. Just like we did with when we solved for the b term in y equals mx plus b. So we're going to replace y with 3. We still don't know what a is. And we're going to do, let's see, 0 minus 1 squared plus 4. Let's go ahead and solve it out. 3 is equal to a negative 1 squared plus 4, which is 3 times, so now 1a plus 4. So if we subtract 4, we get negative 1 to be a, which does match up with what we had originally. So we've got y is equal to negative 1 x minus 1 squared plus 4. And then the standard form we already had. Yeah, the vertex is at negative 2, 3. Negative 2, negative 3, excuse me. We also have another point right there, your y-intercept. So since we don't really need to, we already have a vertex, we can just put everything in the equation at once. So y is equal to a x minus h squared plus k. If it helps you to write down, let's see, it was negative 2, negative 3. That's my hk. And then the xy we're going to use is on the graph. Just so you have it as a reference, that's fine. So let's put those numbers into the equation. 5 goes for y. We are solving for a, so leave it as a variable. X is 0. Okay, now it's minus h. So what should I write here, Bella?
Minus 2.
You're really close.
Oh, wait, sorry, minus 3.
Keely, help her out.
Plus 2.
Plus 2, because then we have to change the sign. So you're right, it's a 2, but we have to add it because it's going to be, here's what it is actually, minus negative 2, which is why it becomes a plus 2.
The way I like to think about that is if you have two minuses, flip one sideways and put them together.
Sure, that works great. Okay, so now you got all the numbers you know, and we'll go ahead and solve for a. You can do that. So it's now 2 squared minus 3, which I know to be 4. A minus 3. We'll add 3. And I'm running out of room. Divide by 4. Did I do something wrong? Okay. So would you please talk with your partner and write down what is the vertex form for this? It's going to be
y equals 2 to the quantity of x plus 2 squared minus 3.
Do you guys agree? Yay. Now, here's the fun part, is writing it in standard form, which you guys did a really good job with multiplying binomials, so I'm really not worried about this. But we got to be able to take this from vertex form and put it back into standard form. So I'm going to do this over here. So y is equal to 2 x plus 2 squared minus 3. We want it in standard form. So remember that x plus 2 squared does not mean x squared plus 2 squared. You have to multiply two of the same binomial. That's what it's saying to you. So we're going to expand this out to be x plus 2 times x plus 2 minus 3. This should look familiar. We're going to do that part. Here, I'll circle it instead. We're doing this part in the green parentheses first. You have to multiply those two binomials. So go ahead and do that. I think you probably still know how. Don't need to watch me do it. Whenever you're done with it, the 2 is still going to be on the outside, and so is a -3. So 2x squared plus 8x plus 8, still -3. And then the last thing we do is that subtraction with order of operations. So let's make that a 2x squared plus 8x plus 5. You know that you did it right because you see that the the y-intercept is 5. So let's write our equation for standard form on the line. Change this point to -7, 1. -7, 1. Otherwise, you're going to end up with like terrible fractions. You're still going to end up with fractions on this one, but they will not be as bad. Okay?
Those are the right numbers.
Yes. Here's what I'm going to do. I will put the answer up on the board, but you need to obviously get there. Let me look. Hold on.
That's right.
Oh, I know what I am. You're good. I forgot to add the 4.
Hey, this is a tough one.